Discussing about another implementation. So in previous session we talked about two-pass assembly scheme. Now we'll be talking mainly about one-pass assembly scheme. Like it was said to be one of the easiest, rather, but again, like it depends how many assemblers do follow it. Majority of assemblers are implemented using two-pass assembly scheme, one which we addressed earlier. Definitely, there are some design changes that had happened with respect to each and every assembler. So what are the standard assemblers? So if you see Turbo assembler, okay, then Microsoft assembler, then NetWide assembler, then yet another assembler. Correct. So these are the four which are said to be popular one. So while I studied assembly programming, I used TASM. Okay. While I started teaching in North Maharashtra University, I worked with MASM. And when I joined Pune University, I worked with NASM and ASM both. But considering like ASM is mostly used by the compiler developers and few other expert ones. So for teaching purpose, like for example, if I talk about databases, which database I will use to teach. So I will prefer to make use of PostgreSQL rather. Okay, on the similar fashion. So in teaching, like if at all assembly programming is to be taught, then mostly NASM is used. Right. And if you really wish to make use of a particular book to understand basics of assembly programming, okay, so let me show you the book. 1 minute. Well, sorry. So let me share a screen with you. Can you see my screen? Not yet. Okay. Now, yeah. So this is the book that you can use if at all you really wish to work in assembly. Okay, Guide to Assembly Language Programming. Now, why I'm referring this book, like if at all you are entering into systems area. Correct. Now, I don't know how many of you are really interested into working in systems area. See, you doing MSc and somebody did BCA or BSc CS or BBA. They all would be working with you. And if it may happen that you are also working with .NET framework or Java, and the other person who did bachelor's probably also would be doing working with you with the same salary. That can happen. Correct. So better in systems, when you decide to enter into systems, there are less peoples and you get good hike. Okay, in terms of salary. So it is always better rather to choose some area which would be good for an individual. So if at all you are expecting to work in systems, so this is say a book that you can refer. Moreover, what I do is like in your third semester of MSc and third semester of MCA. In third semester of MCA, they are supposed to do 5 electives. Now for you, there would be 2 compulsory courses. Okay. Uh, one is I think systems 4 and other one is formal methods 1. Now you have to do a project. Okay, now that project can be year long, or you can do the same amount of, you can put same amount of effort to work with the project and you can finish it in 1 semester only. So that means like if you are working with the project for 2 semesters, then ultimately you are doing project 1, project 2. That doesn't mean that there are 2 projects. Okay, it is compulsory for you, though it is, you must have seen in syllabus, it is said as like, for example, slash. Okay, now why I'm telling you this, I will let you know because it would be really important for us as well. Syllabi. Can you see this? Okay, Now this was your second semester. Now in third semesters you have this particular course as compulsory. This is your second course. Now you can choose one elective. This would be rather one elective is compulsory for you now. Okay, now other things like you can do degree projects. Okay, now every student who is admitted to MSc is supposed to do a degree project comprising total credits to be 8. Now whether you are doing that 8 credits in this semester here or you are doing your degree project in this semester, doesn't matter. Okay, are you with me?
Yes.
Okay, now
Yeah.
suppose let me take example of one or two people from your class. Suppose if I take say Tejas. Okay, Tejas decides that okay, he wants to do systems 4. He definitely is supposed to do formula methods 1, and he wants to do 2 electives. Suppose elective 1, elective 2, and he wants to do 1 degree project. Now, when I say 1 degree project, that doesn't mean that there are 2 degree projects. It means like the project would be comprising load of 2 courses. Please understand this. Load of 2 courses. I mean to say total number of credits would be 8 for it. Fine. So suppose Tejas decides to do 2 electives and 1 degree project. Whereas, like if I take example of say Bhalerao. So what he may do, he may want to do 1 elective and 2 degree projects here. So that is also permitted. So let us not much worry about this. Okay, it is removed already. So now for Bhalerao, it would be what? Only 1 elective is going to do. Okay, and then 2 degree projects he's going to opt here. That doesn't mean that they are 2 degree projects. It is one only, but amount of workload would be of 2. So generally our idea is like students mostly choose 1 project and 2 electives here. Correct. Or and even sometimes like students as they are paying attention towards their placements in the first half. So some of them do choose 3 electives here and they do 2 projects here. So ultimately total number of electives to be done are 1, 2, 3, 4, 5. Now you do according to your own choice. Total number of electives should be 5. Okay, 5 in the sense what? Suppose this is one project. Okay, sorry, this is the first elective, and suppose Bhalerao chosen 2 projects here, 2 degree project course load. So ultimately only 1 elective, a degree project for 8 credits, and these 2 courses. That's his complete workload of semester 3. Now in 4th semester, he will do all of them as elective, except this formal methods too. So 4 plus 1. So by default, everyone is supposed to do 5 electives and a degree project to be 2. Is that clear? Yes.
Yes, sir.
Okay. Okay. Now, how many options possibly could be for you? So choice here is as we are running the system with choice-based credit system, CBCS. Okay. So suppose Tushar wants to do a course in mathematics, and that course is suppose differential equation because he's interested in some say area where he wants to work in a project through the project where he is requiring that differential equation thing. So he can choose that mathematics department course. Now from my side, like you must have seen that in your first semester, I was not there to teach either of the course, correct? So what I do generally is I do offer 2 electives in this semester. Okay, in this semester, third semester. Now those 2 electives are one of them is advanced database concepts, which is with PostgreSQL, and we do teach 2 to 3 NoSQLs along with. And second course I do take is mostly low level assembly programming, where now here we are learning writing assemblers. There we are going to write assembly programs in detail, the way that you must have seen some sample programs while I'm teaching. Okay, they are really very you can say that okay they are really easy programs. We make them as a complicated one. We try to learn how exactly the programs are to be written. But again, it depends if number of registrations are 5 for either of the elective, then I will be taking that LLAP. But I have seen that mostly like 70 to 80% students from MSc MCA together do opt ADC course, okay, which helps them to review database course as well as they can prepare through it. for their placements. If you can have dialogue with your seniors who got placed, some of them really share later, like even companies do ask who taught you this. So then I have been called by majority number of times like, okay, these students are knowing this. So what exactly you teach to them? So I'm not marketing myself, but I'm telling you this thing. Fine. Okay, so the idea behind talking about this part was to tell you like how important your programming part would be. Okay, so that's why like you should start programming in either of the language. So if you are working with assembler and if you are interested in systems, you can continue with both the courses in next semester. Fine, both the courses because both of them would be addressing systems area. Fine. Okay. And there are other courses too which are offered by some teachers like Korpal madam as well as Jyoti madam do offer the courses in that particular semester. Okay, and most like sometimes Damodar sir too. Fine. Okay, so let me jump to now the one pass assembler. Okay, so these are the examples. So if I really see the development that had happened with these assemblers, it is seen that mostly the assemblers designed are two pass assemblers. Now, what is the idea behind having a one pass assembler? So let us see. Now, when we said two pass assembler, you must have seen that we are visiting that code two times because we have to see every time what is the line because first phase is only to really what you can call it as check with whether it is it a valid opcode or not, whether the variable is defined or not. So we actually define or modify or populate symbol table. Along with it, we do generate errors if there are any. Otherwise, output would be an intermediate code. This intermediate code would be taken further. OK, and then it generates an object code. That's what the second page number 32 really addresses. Now, in today's session, we'll be talking about one pass assembly scheme. Now, you may say in two pass, how do we visit the code twice? Now, if you recall the intermediate code that I showed to you, like we wrote there OP number 24. Correct. That means opcode number 24. We have not written that opcode directly. Right? We have not converted the parameters through the mod rm byte. Correct. So now that is why we say we are visiting that code twice and then we convert the code in appropriate object code form. Now with one pass assembler, we are going to do error checking. We are going to enter into symbol table, populate the symbol table, as well as we are going to translate at the same time. That means we are going to visit the code only once. Source code. Fine. That means what? It is going to read our source code or source file. It is going to read that code only once. But problem would be here is the future symbols. Okay, so if you recall, we saw like whenever we are working with some set of variables. Okay, they may be labels. Suppose the code is not defined. Say, for example, let me work out this. So Emacs. Suppose I am writing the code section dot text global main. Now suppose I wrote XOR EX comma EX increment EX CMP EX comma 10 jump pip 0 to my label or jump to your label. And here your label is here. And my label is somewhere here. Now if you see, when we start the translation ultimately, we will start gathering the symbols. So we saw main, we entered into symbol table. We saw XOR, we convert it there only. Conversion of XOR EX would be done at that point of time only. When you see your label, you are going to enter that into symbol table by verifying whether the symbol table contains there the same or not. Now we already got this definition of your label, correct? We move to next increment DX. We got compare. So suppose we converted this to, we got jump my label. Now we will try to check this my label entry into symbol table. Now we identify that my label is not there in the symbol table. That's why we make entry of that table, entry of that label into the symbol table with definition to be undefined. Definition status to be undefined. This is called as future label. This is future label. We haven't identified or came across it, but it is saying that you may get further this my label in somewhere in the code. And that's what is called as future label. Now, what should I do here? What should I put here with my label? I don't have anything to put over here. So I have to keep this as translation as incomplete. This JZ. OK, this JZ, my label we will not be able to translate this. The reason behind or reason about it is what? We don't have address of my label. Now we already saw, like whenever we are talking about this your label, correct? Now from my label, like when we reach to this my label, do we know where is the my label defined? You may not see this because your source code would not be knowing, like your instruction pointer would not be knowing after how many lines this my label is, because it is reading line by line the source code. So until unless it identifies, it will not be able to manipulate it. So that's why this one pass assembly scheme makes use of a data structure, separate data structure along other than the data structures that we used earlier, called as table of incomplete instructions. Correct. So what it does, so for example, this TII data structure would be used as TII, and this would be important only for the one pass assembly scheme. It is referred as table of incomplete instructions, TII. And this is really used for solving problem of future symbols. Correct. This would be used for solving problems related to future symbol. Now, how many such future symbols possibly could be in the code? They can be many. Now, how can I answer that? So I gave you example of what is this? This jump label, my label in this case is a future symbol. This is already known symbol, because your label is already in data structure in your symbol table. But whereas this my label is not there, correct? So that's why we have to work with this particular kind of thing. So this is called as table of incomplete instruction. Because I don't know what to put with my label, because if you recall when we saw how the forward and backward instructions are taken care of, we said that whenever there is a forward instruction forward reference is there. So like when I say incomplete future symbol, incomplete instruction as well as future symbol, and this is also called as forward reference, and this is called as backward reference. Okay, now this forward reference, we saw that it is going to count only the number of locations that needs to be jumped further. For backward references, we saw that a 2's complement approach is used by the system. Somebody asked me once a question. I don't know whether that particular, I don't recall even the name of the student, but if he is available in the class, he can speak. I don't recall his name. Tushar, there was one, Nanesh, I think you asked that question that day. I don't recall exactly the name, because his question was why exactly this two pass, the two's complement approach is used for backward reference or backward jump, and why it is counting the bytes from next location when we do talk about forward reference. That's what we saw, correct? Now for backward, because it has to go back to those bytes, that's why those 2 bytes are also computed whenever it is a backward reference. But whenever it is forward reference, it has to count only bytes after that address. So that's why that count is kept. So from next line, it is going to pick the number of bytes. For backward reference, from the same line, the number of bytes would be computed. Is that fine? Do you want me to repeat this? So what we said, backward reference start counting bytes from current line, and forward reference start counting bytes from next line. Fine. And this makes use of convert that count to or compute. And here you straight forward really go along probably by computing the number of bytes. So it is pretty easy whenever it is forward. But when you are talking about backward, then definitely it will be a tricky judgment rather in implementation. And when we said that like this table of incomplete instruction is to be used. So what exactly it causes to do so? So what exactly it started? So if I see, I started with section.data, for example, I will apply the same strategy which I applied earlier in the 2-pass mechanism. Section.data, section.text, sorry, section.data, section.ro data, and section.bss. Same procedure would be applied, like having a location counters to be different. Now my instruction pointer comes into picture when I do talk about section.text. Fine. So I will start reading the line from the source code, check whether it is end of file. If no, check whether it is a label. OK, if no, then go and read the line available there. That means you are going to read the opcode. OK, if a symbol is used in that opcode, search into symbol table, otherwise make its entry. If symbol is not used, then ultimately you are going to work further with respect to translating the code. Now, in what sense? You will try to assemble that line. Assemble, I mean to say, like you will directly write opcode, you will directly make use of mod rm byte there, with assumption that you verified that it is a register, it is not a symbol. Now, if it is in symbol, then symbol table entry would be there, and that instruction will try to search whether symbol table entry contains address for that variable. If not, then it would be treated as forward reference. So it will be entered into table of incomplete instruction. So how the form would be, we'll discuss what should be the form. But some point of time you have to take care of this TII. Fine, because you could not translate that line. So every line which contains a symbol definition in a symbol table with definition status to be U, then all such instructions should be translated at later stage. And that's why this TII is referred. Right? And this is one of the trickiest assembler to implement, because how will you jump directly to that line and try to fit the address which would be available after the conversion for each of the forward reference computation. Backward reference, it is very easy for implementation perspective, but forward reference is one of the tough tasks. So how the table of incomplete instructions would be? Now, as we saw that instruction, for example, if I talk about JZ my label, So it will only apply JZ. This line, it will keep as it is in the memory. Address of this would be kept, and address of this instruction would be added into TII structure. So it would be like instruction, then symbol table entry. Okay, entry number, because as it is not defined yet, this my label is not defined yet. That's why. And actual translation. Suppose I will take these three columns. Instruction, miss, you can take line number 2, 4, 1. Line number, then instruction, then symbol table entry. If at all it is making use of some symbol, with assumption that that symbol is defined. If it is not defined, then only you are going to enter into TII. Otherwise, TII implementation is not necessary at all. Correct? Any question till this? Yes, please. Bashir?
No, sir. Thank you.
Prerna? Sahil? Seher? Salim?
Yes.
Any question? Tushar?
No, sir.
Okay. So this will be one of the trickiest one when you talk about this line number. Then when should we convert this? So a temporary code is generally always used. So if you recall, in once I showed you like that through GCC, how can you create temporary files? Because when you write GCC, ultimately an executable is generated every time for C code. Because until unless you write -C, -E or any other thing, correct? Otherwise, it is very difficult. Difficult in the sense to get those temporary files. With the translation, every time that files are created. Now think of this, how my voice is reaching towards your end. So there is no delay, probably with assumption that there is a network connectivity. So let me take a sample example here. I assume that system should work. Let me check. Okay, let me log in. Yeah. So let me share the screen. Can you see my screen? This is for Office 365. Fine. Now you will see here, like, for example, let me delete this. And there is this mic. So whatever I'm speaking now, it would be automatically typed, because this is kind of demonstration that I'm probably trying to make use of to show you how exactly or what kind of delay possibly could be there in terms of reading the text, or what are the words that are spoken by the speaker, translating them in terms of set of words. Now, in this case, you must have seen rather, let me stop that. You must have seen here, like it hasn't picked each and every word that I spoke. So from where exactly it is storing that data? Now see, remember the speed that I'm using while India is my country, or Indians are my brothers and sisters. So you must have seen it took some amount of time rather while I'm speaking, right? And it is trying to identify that word, and then ultimately the reframing is done, right? Initially it writes some wrong word, then automatically it would be changed whenever it finds a correct replacement for that text. Right? Now I assume you must have seen this demonstration. If you recall, I said now I assume you must have seen this demonstration, but what it took this no. Correct. So let me stop this. So while it is reading, while it is keeping information about what words are spoken by me, they are stored in some temporary file, which is not shown here in front of us. Is it shown? No, but there is some delay with respect to the word that I speak and the word it types. The word I speak, the word it types. Correct. Now every time you will not see that the word I speak ultimately same amount of time that word is getting displayed. Correct. Now you should have seen the delay that is visible to us in terms of what exactly the system is trying to do. That means what it is storing these words, what are the word that I have spoken rather in some format, and it is going to use that format and will try to see a perfect matching of the words which possibly could be there in its dictionary. And when your match is found, then it displays that text. Sometimes you will see some wrong words also can be added when I never probably might have said the same word. Correct? Are you with me?
Yes, sir.
Now, when I say this, ultimately, even like the amount of speed that I use to speak, sometimes you may require to see that lecture probably later again and again. Every time, suppose this recording is available to you. Now, if recording is not available to you, say for example, in the class, you are supposed to ask me, sir, can you please control yourself? Can you speak little slow so that whatever you are speaking can be understood? Then ultimately what can happen is I can make use of the speed which would be suited to you. Now, in this case, you must have seen rather the way I am simply running through the code. It would be very difficult for me to map the system. Now, try to match it. Correct? Try to match this. It seems very difficult. So the system definitely is collecting that data, keeping it some file, and when translation is done, when it shows this at the initial level, you will see see the font color when I start speaking. Huh? See the font color. When I start speaking, try to address the font color. It is not really black, but when I stop, ultimately the text is converted to black color. Now see. Correct? That means what it is storing that information somewhere where it identifies that correctness to be 100%. Then only it writes that into the file that you have opened in front of you. I have opened in front of you. Otherwise, it tries to match with the appropriate word available with its dictionary. Correct. Now you must have seen with its dictionary it added twice in this case. Now suppose if in between I start talking in Marathi, Salto Kare. Now let us see. Now you might have seen it hasn't understood Salto Kare word. It tried matching it with its own directory structure or dictionary which is available with it to match the proper or fixed match rather. And that's why like every time while you do talk about probably this translation, the system would be definitely taking care of by simply creating so many temporary files which could be deleted at the later stage. And mostly they are deleted, they are not stored. And that is the reason why you require some amount of space whenever you are trying to install Linux operating system. Is that fine? Any question? Mahesh? Nanesh? Sahil? Sneha? Can you hear me?
Yes, sir.
Okay. Okay, what Nanesh, what is no? What do you mean by no, sir? No, let me know why exactly you wrote no. You can unmute and let me know what is your question. You can speak in either of the language. If you are not able to speak in or put forward your problem in English. Now let me show you probably one demonstration. Okay, no doubts. You are saying no doubts. Okay. Okay, I thought you haven't understood. Thank you. So like I'm referring like same book rather. Okay, you can use page number. Let me tell you. Page number. There's a flowchart given. So page number is 36. Okay, then 37. These are the two pages which contains an algorithm. Okay, for this. So in next class, like I will be demonstrating you probably how the macros are used by the system and how the translation is done. So we are going to see new data structures for macro preprocessing. So you should start working with your assembler. Okay, this assembler code that you are going to write on your own would be carrying definitely like minimum 10 marks to maximum 20 marks. Okay, in your internals part. And it should be your own design. So you have to choose one of the assembler, either a 2-pass or a 1-pass assembler, and start with the instruction set that you are going to pick is Intel 32-bit instruction, the program that I showed you. Okay. Fine. Okay, so I will stop here and we'll continue probably in next session again, where I will be addressing mostly